Hello and welcome to another session of PMCD Maths Teaching, and this time we're looking at finding gradients of straight lines. I just want to, before we get started, I just want to show the rationale of why I'm taking this approach with teaching gradients of straight lines. Okay, so really what I'm trying to get away from here with this is just relying on or seeing maths as a series of calculations or formulas to get answers, but not really understanding the root of where those calculations come from. Therefore, not really having a connection to, in this case, what the gradient is. So this is the approach that I've sort of taken with the teaching of gradient. In terms of sequencing, this is where I would have sequenced this ideally. And we're looking at, probably the fourth stage of that. And it might take more than one lesson, some of these, but and just to point out features of straight lines, I'm also going to be putting a video up of a lesson I do with that, which uses GeoGebra to get them to find out the features of straight line graphs. Okay, but we're going to focus on the gradient here, and you could see in the first picture this sign here, which many students would have seen. We've all seen these, but do they really understand, or do many adults understand what this actually means? They think the higher the number they know, it's steeper it is, but why? What's 20% got to do with it? And this sort of loops around this lesson to get to that. Okay, so where do I start with this? Well, as a sort of starter to warm up, okay, I usually get students to look at how they convert fractions to a denominator of 1. And the idea of this, obviously looking forward, is we're looking for the gradient is how quickly, or quickly is not a bad way of describing it. How quickly does a line, or how much does a line rise or decline for every unit increase in the x direction? And so eventually when you go to the formula method, you're looking at that as the difference of y, and that's the difference of x, and we always want to reduce that to 1. When we do the gradient, really the denominator ends up being 1 here. So this is what I want them to get into the habit of thinking about at this stage. Okay, so the process, obviously, there's lots of different ways, obviously, of doing this, but 12 over 4 they could write as 3, but I'm looking at, what do you do to the denominator here? You divide by 4. Okay, what happens to the denominator here? We divide by 8. And I think there's nothing wrong in this one, actually, you can put it as a decimal, but writing it as, you could write it as 3/8 over 1, or 0.375 over 1. And that's a fraction within a fraction, but the idea is it's right, when we get to the explanation, the line is rising or declining, if it's a negative gradient, by 3/8 of a unit for every 1 unit increase in the x direction, or horizontal. Okay, so that's a little warm up for what's coming up later on. We can do a little bit of practice with this one as well. Can we make them have a denominator of 1 to make that comparison? Okay, so this has got other benefits for GCSE style questions, which are a bit abstract in that way. Then what I've done is I've used a local photo to our school, where I actually found this sign. So I took a picture of it and I put this on there. And it's quite surprising, actually. It's not far from where the school is. It's quite surprising how many of them haven't even seen the sign. So walking around with their headphones on, their heads down by the looks of it. But anyway, there's enough of them to actually realise what's going on. 8%, what does that mean? Okay, so let me sort of discuss, okay, what would be steeper than that? We get to talk about 100%, what's 100%? And a misconception there, obviously, that the 100% is a vertical climb or vertical decline for a hill going down. That's something you can explore later if you wish, but I think it's quite interesting conversation started from that. So then going on to that, I want to get them to consider, just by looking at those lines, and I would say, think about this, if you were cycling or you were walking up a hill, which is the steepest, and we've got the literacy here, gradient meaning steepness, okay, and explain why. Okay, so by this time you get a bit of maths dancing going on in the classroom, hands going in different directions, which I always find quite funny, and play along with, but yeah, can they use words to do that? To encourage that, a lot of the time I've got at school, I've got one of these sort of telephones with a cord, and I'll say, oh, I'm on telephone, I can't see you, I need you to explain this to me. And I'll close my eyes and I'll, play along with it a little bit, but it forces them to try and use words to describe what's going on. And it's quite difficult. We know that with maths, it is quite a difficult thing, but the more we can verbalise, the better understanding they will be showing that way, if they can verbalise what's going on here. So, okay, I think they all could get a vote on this. They can all actually say that the red one is the steepest, the black one's the second steepest, and the purple or the pink one is the least steep. Explain why. Can we give it a value? Okay, now the squares are there. So, okay, one way of looking at this is, well, why is the red line steeper than the black line and the pink line? Well, let's take the red and the black. That's probably the easiest ones here. Okay, and they do sort of say, we do eventually get sometimes to the point where they're looking at, okay, well, it's rising very much quicker as you go horizontally. Now, you may have to tease this out then, okay? But, and then can you give this a steepness value? So okay, so we've started there on A, we started there and we finished at the end of the line now. So what have we actually done then? We've moved 2 units horizontally, and we've moved 2, 4, 6, we've moved 8 units vertically. 2, 3, 4 units horizontally for C, and 1, 2, 3, 4 units vertically. And let's do B while we're at it as well. 1, 2, 3, 4, 5, 6, 7, 8, 9 units horizontally, and 3 units vertically. That's hard, isn't it, to compare, get across, because they've all moved different distances horizontally. So it'd be nice if we had a comparison which would be the same. So, how can we get a steepness value for this? It's very, very difficult. But if you're talking about using these, there's 2 options, isn't there? You can either do vertical divided by horizontal, or horizontal divided by vertical. But if you're thinking about it, because you really compare it, you're seeing that's the steepness. That's what's telling us what the steepness is that comparison between how far we climb or decline for every unit we travel horizontally. So we could have 8 over 2 or 2 over 8. And at this point, we'll say, well, okay, can we convert those to something over 1? So it links into what we've done earlier on. And they can divide top and bottom, or numerator and denominator here, by 2 to get 4 over 1. And if I did the same with this, I divide numerator and denominator by 8, you end up with a quarter over 1, or just a quarter. Okay, as your grading. You can put it over 1 if you want to. Okay, let's compare this one here. What would that be? That would be 4 over 4. Well, we get 4 over 4 either way there, don't we? 4 divided by 4. We can work that out. It's actually 1 over 1, or just 1. And just to emphasise, obviously, all whole numbers can be written as fractions over 1. So 4 over 1 we tend to write as 4, not 4 over 1, and 1 over 1 we tend to write as 1. Okay, so which method makes sense? Is it vertical divided by horizontal, or horizontal divided by vertical? And obviously, a bit of discussion here. You can see that it's vertical divided by horizontal because that gives a number that's larger, the gradient here, than the gradient is here. And we're going to check it out with this one here. So it can either be 3 over 9 or 9 over 3. Could have been worked out that way. Does that fit? Okay, well, 3 over 9, if we convert that to a fraction with a denominator of 1, divide numerator and denominator by 1, we get third over 1. Excuse my mouse writing there. The third over 1, or a third, and this one's 3 over 1. Okay, so what we're saying then, we're getting 3 over 1 or a third. Now, the temptation obviously is always to divide the numerator by the largest number by the smallest number. We know this is the least steep, so actually the gradient of this line, let's try and get that a little bit clearer there, is 1/3. Let's just see. So if we stick with vertical divided by horizontal, which is what this simplifies to, we get 4, we get a third, and we get 1. And that fits, doesn't it? Okay, so we've sort of got a method we think that works here. And you can introduce other words like rise and run there, if you like, if they've heard those words before. I tend to stick with horizontal and vertical, then it translates to, for me, to the Cartesian grid a little bit easier. But, there's no fixed rule on that. Okay, so just a little practice then. I might give a little mini whiteboard activity where they've got to find these gradients. So I've got 2 lines and I've showed them how far horizontally and vertically these lines have travelled. So, and then I'm again focusing on getting them to write it's a fraction over 1. Okay. Now that gives me the understanding of where they are. I might need to give some further explanation before we go on to the actual main activity here. So the main activity is, and this is where I tried to, challenge is here, where is the steepest road in the world? So I've done a bit of research, and you can do your own with this. So I'm not saying this is 100% true, what I've put down here, but this is what I found out anyway. So I found some places around the world, got some information about parts of it. It's not, not full steepness of the whole road, maybe sections of the road that have this particular steepness. So there's other discussions here, how accurate is what I'm saying anyway, but this is what I've got here. And I will try to give access to these resources, but you can get your own with this. And part of what I'm doing with these teacher training things is to try and encourage people to be creative, make your own resources. Mine can be improved on, no doubt about that, but making it your own gives you more of an attachment to it, probably going to make you enjoy it a little bit more rather than just picking up something that I've done and working with it. But you can have what I've got if I can put it up, if I can attach it, then you can definitely have that. Okay, so these are the places. Baldwin Street in New Zealand, Guinness Book of World Records talks about that being the steepest here. And there's a few facts I put on there to try and make it more interesting. I mean, they are pretty impressed by the steepness of these roads as well. These actually are roads that exist in the world. Harlock in Wales. Okay, San Francisco, as we'd probably expect. And each of these has got a little bit of information. Street rises from 27 feet. So it's not just telling you the rise and the run, or the horizontal and vertical. They're actually going to have to do a bit of work here to think about this. And this one actually was used in an Audi advert to talk about its handling, I think, in the snow. And that link there, that extended link actually goes to that advert. Well, it did. I hope it still works. Eldridge Street, Los Angeles. Waipa Valley, Hawaii. And okay, so I've got a little table here. What I'm asking them to do is draw a little diagram, give me the horizontal and the vertical. Yeah, so I've got rise and run there, horizontal and vertical. What calculation did they use and what's the gradient? And then I'm asking at the end to write it as a percentage. Okay, so that might be something you have to bear in mind if you want to do that. And the reason for that is I want to link back to that sign that we had right at the start of the lesson. Okay, how do these gradients compare to the gradient that's just down the road from the school? And leading on from that, then once they've done that, the next step would be, and this might not be in the same lesson, is that they can now use that knowledge to try and work out the gradient from a graph by thinking about, now they're trying to identify the rise and the run, so hopefully that makes a little bit more sense to them. Some positive and negative gradients there. And the green task is put on here at the end is if they're flying with that, then okay, I'll give them some coordinates. Can they find the gradient between 2 coordinates? Encourage them to draw the graph for that as well. Okay, so that's pretty much where the gradient lesson stops then for me. And then, I would move into the next lesson. I'll be thinking I'd be ready then to start looking at finding equations of straight lines. So as I said, I'll try and put the information, the worksheets that I've got there, try and attach those, put them somewhere that you can get hold of them. As I said, be creative yourself. You might have some better ideas. I'd love to hear what they are. And enjoy it. This is something that actually I used to hate teaching, actually, when I first started teaching, because I found it was always sticky. And what I mean by that is the students there was always lots of questions about what to do, but I found doing it through this way, first of all, they're really interested because I can swap these, they swap all these sheets around. They're interested in the places where the gradients exist. But, while they're doing this, they're gaining that sort of, as I call it, intuitive understanding. It's something they're aware of because they've probably walked up and down hills, so they can feel it, they can imagine what those gradients actually feel like. Anyway, I'll be very interested to hear about how you've actually, how you get on with that, if you do use that, and I will see you next time. Thank you.